So this vessel right here is going to take oxygen poor blood out of the kidney, but blood that contains filtered blood, okay? So it's filtered blood, it's low in O2, and this is gonna be the renal what? Yep, renal vein. All right, the renal vein is going to connect right into this major vessel that takes the oxygenated blood back into the heart. What's this major vessel called? What is it?
Back to the heart.
Abdominal aorta.
No.
Back to the heart.
You turned around so quick.
Inferior vena cava.
Wait, oh no, my notes say something completely
Aorta
different.
is coming from the heart.
No, my point is the same thing that he's drawing right now.
I have a bone aorta.
No, you have that too? Okay.
Well, hold on. We're gonna get to that, hold on. Okay, so the renal vein. So the the renal vein is going to pipe into the inferior vena cava. Yes?
Yes.
Yes. All right. Now, this vessel right here that goes into the kidney that is going to contain oxygen-rich blood, but blood needs to be filtered. It's called the renal what? Artery. Very good. Renal artery. All right. And that is going to come from the what? Abdominal aorta. Very good. So, on your lab practical, if I were to ask you or show you an image showing you that the renal vein is coming from the kidney and connecting into the inferior vena cava, make sure you're able to identify the inferior vena cava. If you were to see the image showing you the abdominal aorta, which is a red vessel, and there's a little branch coming off that going into the kidney, that's the renal artery, and that's the abdominal aorta, okay? And then this tan structure that you would see on the model, what's that called? Is it the urethra or the ureter? The ureter, very good. All right, so that's the ureter. All right. Bladder, you don't have to, you can identify that kind of easily. And then what's the vessel that comes off the bladder that takes the urine to the outside world? Urethra, very good. All right, let's talk about this. We talked about how you got the renal corpuscle, and it's composed of the glomerulus, and it's composed of the glomerular capsule. We talked about how you got the proximal convoluted tubule, the nephron loop, and then the distal convoluted tubule. We've got that. So PCT, DCT, this right here from here to here is going to be the what's it called? Old school term is loop of Henle. New school term is nephron loop. And so this right here, this is going to be the descending limb. So if I were to ask you what substance is reabsorbed off the descending limb, what would you say?
H2O.
Water. Very good. Okay, so water is going to come out. All right, and then if I were to ask you what this limb is, you would say that this is the ascending limb. Not bad. And then what diffuses out of the ascending limb? Electrolytes, very good. Okay, so anything that has a charge, sodium chloride, magnesium, magnesium chloride, calcium, those are all electrolytes, bicarbonate. And so the next thing I'd ask you is this, the countercurrent multiplier, okay? Countercurrent multiplier. So be careful with this one. The more electrolytes that are diffusing out, the more what is diffusing out? Water, okay? So the more electrolytes, the more water, okay? And that is the countercurrent multiplier. If we have fewer electrolytes diffusing out, we'll have fewer amounts of water diffusing out. Water is the solvent and the electrolytes are the solute. So the solvent likes to mix. So if there isn't a lot of solutes diffusing out, there's not a lot of water diffusing out, okay? Yes? Yes. Okay, questions on that? So when you get to that question, there's two parts to it, read it carefully. So it's gonna ask you about the counter current multiplier. And so the first part of it is gonna ask you what diffuses out on the descending limb? Water. What diffuses out on the ascending limb? Electrolytes. Check, check. And then from there, there's gonna be a question asking you about the relationship between the two. So the more electrolytes, the more what diffuses out? Water. Very good. Right now, as all of you are sitting there, your total GFR, your glomerular filtration rate, GFR, is how many milliliters per minute? 100, 125, or 300?
125.
125, very good. So every minute that passes by, you've got 125 milliliters